Hello guys, in today's video we are solving a previous question paper, physical science paper 1. It was written in November 2021. So without wasting any more time, let's get into it. A hot air balloon is moving upwards at a constant unknown speed. 1.1. Is the hot air balloon in free fall? Yes or no? Give a reason for an answer. So we have to know the definition of a free fall. A free fall is when an object is experiencing only gravitational force. So if an object is falling from the sky and there's no other force that is acting on the object, that object is in free fall. So the situation with the hot air balloon, they say it's moving upwards at a constant unknown speed. So this means there is another force that is acting against the gravitational force. So if there is another force, then this thing is no longer a free fall. So 1.1. The answer is no, it's not a free fall. Reason: gravitational force is not the only force that is acting on the object. That is the reason why we say no. The balloon, the hot air balloon is not in free fall. Then let's continue with the question. When the balloon is 200 meters above the ground, a small stone A is dropped from the balloon, and another small stone B is dropped 5 seconds later from the balloon while the balloon is still in moving upwards at a constant velocity. Stone A strikes the ground at the speed of 62.68 meters per second. So we got all the information. Then calculate the speed of the hot air balloon. So from the information, we're told that while the balloon is moving upwards at a constant velocity, someone dropped a stone. By the time the stone was dropped, the stone didn't go down immediately. It, it kept moving at the speed of the hot air balloon. That means the initial velocity of the stone is the same as the velocity the balloon is traveling at. So to find the velocity of the balloon, we have to find initial velocity of the stone, because the only information that we have is the information of the stone. So we say 1.2, we are told v, which is final velocity, equals to 62.68 meters per second. And then obviously we've got a gravitational acceleration, which is 9.8 meters per second squared. And then we've got change in position, which is 200 meters. We've got the distance. The distance is change in y is equals to 200 meters. So with this information, we can use the formula v squared equals to u squared plus 2g, the change in position, which is s. So another important information that we have to keep in mind, a direction need to have a sign. Like I will say, when it goes down, the sign is positive. So let's substitute. V squared is 62.668 squared equals to u squared, which is what we are looking for, 2 times 9.8 times 200. Then you have to make u squared the subject of the formula. I will say u squared is equal to 62.68 squared minus 2 times 9.8 times 200. This is minus because this is one term. So I just take this term and then move it to the other side of the equal sign. Then it changes the sign. So equals to, here I'm gonna need a calculator, 62.68 squared minus 2 times 9.8 times 200. So u squared equals to 8.782. This is u squared. So what we want u. So we are going to put u, the square root, and then here we put the square root here. Then because it is squared, then squared is going to remove the square root. So u equals to plus or minus the square root of 8.7824, then which is equals to, let's say, root of an answer, then u is plus or minus 2.96 meters per second, because it's the speed. So because we say when something goes up, it's negative, the upwards direction is negative, and then the hot air balloon is moving upward. So here we are taking the negative answer. So that is mean the answer is negative 2.96 meters per second. This negative represent upwards direction. And then the other answer, the positive answer, remember the stone, while it was dropped, it goes up, and then turn back and goes down. So here is the negative answer, this one. And then when it goes up and then reach the same position here, like this position, that is where we get the positive answer. Remember, the information we used here is for the stone, it's not for the air balloon. It's for the stone, but the stone and the hot air balloon, the initial speed of the stone is the same as the hot air balloon. So that's why we've got two answers, but we only need one, the initial one. So now I'm just adding the information. Alright. The positive answer is for the time the stone comes back and then goes down. This is the positive. And now we are going to question number 1.2.2. Question number 1.2. Calculate the time it takes the stone A to strike the ground. So now we have to calculate time. Remember, the stone movement is like, it has moved like this. This is where the stone was dropped. This is when the stone strikes the ground. So we have initial velocity from here, which is negative 2.96, and then we have final velocity here, which is 62.68 meters per second. Here it's negative 2.96 meters per second. So we have to calculate the time from here to here. So I will calculate time from here to maximum height. Then after that, I calculate time from maximum height to the ground. Then after that, I add them together, then to get the total time. So I will use the formula V equals to U plus G T. And then from here to here, initial velocity is negative 2.96, and then final velocity here is 0, because here it's when it stopped, it's preparing to go down. So I'm gonna say 0 equals to minus 2.96 plus 9.8 t. And then if 2 negative 2.96 jump the equal sign to the other side, it become positive, then I will divide by 9.8. So t equals to positive 2.96 divided by 9.8, which is equals to, and then 0.96 divided by 9.8, which is 0.302 seconds. This is the time from is the time when the stone was dropped until it reaches a maximum height. So now we are calculating the time from the maximum height until it reaches the ground. So same formula, V equals to U plus G T. And then final velocity now it's 62.68 equals to initial velocity from here, because here it had stopped. So 0 plus 9.8 t, and then t equals to 62.68 divided by 9.8, and then 62.68 fraction divided by 9.8, which is equals to 6.396. So second. So the total time is this time plus this time. So t total equals to 0.302 plus 6.396 point zero sorry 0.302 plus 6.396, which is equals to 6.7 seconds. This is the total time from a time when the stone was dropped until it reaches the ground. And now we are at number 1.2.3. The question says calculate the distance between hot air balloon and stone B at the instant when stone A strikes the ground. So, and what we are told from the information, stone B and stone A, they make the same motion, but the only difference is the time. One was dropped 5 seconds later than the other. So, initial velocity of the stone A is the same as initial velocity of the stone B. To find the distance between, we have to find the distance that was moved by the hot air balloon and the distance that was moved by the stone. So let's start by the hot air balloon. Because the hot air balloon was moved at a constant speed. So we can use the formula of average velocity that says average velocity is equals to distance over time, because we are looking for a distance. So we can say changing position is equals to average velocity, which is constant, multiplied by time. Then velocity, it's negative 2.96 multiplied by the time for the stone B is this one, 6.7 minus 5, because it was dropped 5 seconds late. 6.7 minus 5, so which is negative 2.96 multiplied by minus 5. So here we get negative 0.032 meters, because we said when something goes upwards it's negative, so this negative, it only tells us the direction that the hot air balloon is going up. So actually the answer is 5.032 meters. So now you can find the distance moved by the stone B. And remember, stone B initial velocity is the same as the initial velocity of the hot air balloon. So we have initial velocity, we have time, and then we have gravitational acceleration. So we can use this formula because we've got gravitational acceleration. So we can use the formula for average velocity. So we need to have acceleration, which is g, then t squared. I'll use this one. Changing position is equal to initial velocity times time plus half times g times time. And then initial velocity we know is negative 2.96. It's negative because the stone started by going up first before it goes down. So we have to put negative here. It's gonna be wrong if you put positive. Multiply by time, it's 6.7 minus 5, then plus half 9.8, and then here time is 6.7 minus 5 squared. And then you can say negative 2.96 into 6.7 minus 5 plus half 9.8, 6.7 minus 5 squared. So this one is positive, so it shows that it's going down. It's 9, 1, 2, 9. So to find the distance between the hot air balloon and the stone B, we add this time because one is going up, one is going down. So we're gonna have 9.1, let's see, 0.129 plus 5.032, then say plus 5.032, which is 14.161 meters. This is the distance between hot air balloon and the stone B when stone A reaches the ground. This is the distance. Now we are on number 3.3. 3.3 say on the same set of axes, draw position time graph for both the hot air balloon and the stone A from the time the stone A is dropped until it strikes the ground. Use the ground as zero reference. So here we are going to draw a graph. So it's a distance time graph. It's a distance time graph. Because if you remember, we used positive as downwards motion and then negative as upwards motion. So our graph is going to be on the negative side of the y-axis. This is y, this is x. So this side is negative, this one is positive. So they say the hot air balloon and the stone A. Remember, hot air balloon was moving at a constant velocity. So like say the velocity goes like, because it's increasing, so increasing, the negative numbers are going up. This is the hot air balloon. And then stone A. Stone A started here and then goes like, then goes down like this. This is the stone A. Because they say we must use 0 as the ground. So this is 0. Then stone A goes like this.